All right, let's go ahead and start with 4.3. So we're going to divide. And so you'll remember from elementary school, if I did 90 divided by 2, right? You'd have to do the division algorithm here. So you'd have to do 2 goes into 9 4 times. 4 times 2 is 8. Subtract, you get 1, bring down your 0. 2 goes into 10 5 times. So then you have 10, because 2 times 5 is 10, and you end up with a 0. We're going to do the same thing here with polynomials. So it looks kind of intimidating, but remember, we're only going to look at one term at a time, and we're not going to care about anything that comes after this. So if we look at this other problem here, I'd really only care about looking at this one, and I'm not going to look at anything after it, yeah? So let's go ahead and write this out. So this is going to be, use parentheses because we are polite, like this, okay? I'm not going to use parentheses in the bottom portion here, but what I am going to do is I'm going to add placeholders. So I'm missing a 0x and I'm missing a constant term, right? So if I add 0, I haven't changed anything. It's kind of like your bank account. If you don't put any money in it, it's not going to grow or shrink or anything like that, right? Well, if you don't touch it at all, that is. All right, so x squared goes into x to the third. How do I make x squared into x to the third, right? So that would be x squared minus 16. I want to make this look like this. And the best way for me to do that is to multiply this by an x, right? So just like we were multiplying our 2 and our 4 here, we're going to do the same thing. We're just multiplying an x now. So this is going to give me x to the third minus 16x. So I'm going to write this in here. Use parentheses, x to the third minus, oops, can't put it there, so you have to put a 0x squared. So plus and then minus 16x, right? Because we've added 0. We don't have an x squared here. We're missing our x squared, right? We're going to subtract from our line. X to the third minus x to the third. Well, that goes away. That's nice. This is going to leave us with negative 4 minus 0. So negative 4 minus 0 is still negative 4. Still have that negative balance, you know? Then we have 0 minus negative 16. Well, a negative times a negative, right? If I rewrite this out, that would be 0 minus negative 16, which is 0 plus 16, right? So that's going to be plus 16x. Drop my 0 down. Not that it makes much of a difference, but it will help us in the long run, okay? And I also do my placeholders even if I don't think that I'm going to need them. You never know when they're going to come in handy. So this one, I need x squared to start looking a lot like negative 4x squared. That means I just have to multiply by negative 4. So negative 4 times x squared minus 16. Okay, well that's going to be negative 4x squared plus, because negative times negative, 64. Okay. Now notice that I am missing an x term. Where's my x term? Well, there is none. It's 0x. So that's what we're going to make sure to put down here. So parentheses, negative 4x squared plus 0x minus 64. Yeah. And then we're going to subtract those two things. Well, that makes life easy. That cancels those two things out. That's 16 minus 0 is 16x. And 0 minus negative 64, again, that's another situation where we had to distribute the x, or the negative, right? That's going to be plus 64. Okay. Oh, I made a mistake. This is plus 64. Oops. And you might have noticed this before I even wrote it down. This should be negative 64. Because we've got positive 64 here, and what I did was I accidentally wrote this as negative 64. Okay, so not too bad. And we're about to get into the next one here, which hopefully is synthetic division. So we have another thing of long division, which we love. And then here we go. Let's do some synthetic division, because it says here synthetic division. Okay, synthetic division is the one that everybody seems to love. And I refused to learn it when I was in high school because I thought it was harder. And then when I started doing a lot of like higher level math, like abstract algebra and like even relearning some of this stuff for my work and teaching and all that a couple years ago. I just said, I'm going to learn synthetic division. 100% made my life easier. Shouldn't have been so stubborn, but here we are. So first things first is you're going to take this portion here, and you are going to write this in as x plus 2 equals 0. And you're going to solve for x. So you get negative 2. Next thing we're going to do is we're going to label our coefficients, because sometimes that helps me a little bit. This is going to be 1, this is going to be 4, this is going to be 6, and this is going to be 4. Okay? So this is a constant term, but I'm going to treat it as a coefficient for now. And now we're just going to set it up. So I'm going to set my L-shaped graph here. I'm going to write negative 2 here. So that comes from here to here. Yeah? And then in green, I'm going to write down each of the coefficients in my constant term. So 1, 4, 6, 4. And if you need to put in placeholders, right, there will be a time where you might need to put placeholders in. You can just put zeros in. Just put the number 0. That's all you have to do. Okay? So now we're going to go ahead and go through the whole process here. And you know what? I'm probably going to do this one. I'm just going to set 7 up so you can see it when we get there. Okay. So drop this down. You have a 1. Negative 2. Oops. So drop this down. You have 1. So you're going to multiply, and then you're going to add. Okay? So negative 2 times 1 is negative 2. And 4 plus negative 2 is 2. Negative 2 times 2 is negative 4. That's going to leave you with a 2. Because negative 6 plus negative 4 is 2. And then we're going to have negative 2 times negative 2 is negative 4. And this is where your remainder is. It's on that last bit of information here. And the remainder in our case is a fun 0. Okay? Let me check something over on this end. Beautiful. Okay. Down here, I'm just going to set this one up. Okay, so this one had a 2. We're missing an x term, an x squared. So that's going to be 0. We're missing an x, so that's going to be 0. And then we have our constant term, which is 54. Then we have x plus 3 equals 0. Well, that's going to be x equals negative 3. So negative 3, 2, 0, 0, 54. Drop your 2. 3 times negative 3 times 2 is negative 6. Negative 6, positive 18. Negative 3 times negative 6 is positive 18. 18. And then we should get negative 54. And you'll notice that this is not going to be 0 this time. This is going to be negative 108. Okay, now let's go ahead and take a step back here, and let's learn how to write these solutions now, right? So for number 2, and I totally forgot to write them in on the top, and that's my fault. This is going to be, we multiplied by x, what was the first thing we did, plus, and then we did negative 4, so that's minus 4, right? Okay, so the answer is going to be x minus 4, okay, plus your remainder, 16x minus 64, over this piece of information here, x squared minus 16, okay? And that is how you write the final solution with a remainder, okay? Back over on this end, we do the same thing, except for there is no remainder for this one. It's 0, right? So I'm going to show you how we traditionally write it, and I'm going to show you the quick way of writing it, yeah? So this is going to be x. So we started with a third, so we need to drop it down to the second power now, yeah? Because we've divided it out by an x. So this is going to be x squared with a leading coefficient of 1 plus 2x plus 2, okay? So it's going to be x squared plus 2x plus 2. And my remainder is 0, so we say plus 0 over x plus 2, okay? well, 0 over anything is 0, so that's x squared plus 2x plus 2. Now, you don't have to write the remainder over 0 because you know it's just going to be 0, right? So you can just write your final answer right here. So same thing down here. I'm going to say that we started with a third, so we need to go to the second power now because we've divided an x out. And what I mean by that is if I do x squared over x, that's the same thing as x. Okay? So this is going to be x squared minus 6x plus 18 minus, because our remainder was 108, so this is going to be 108 over x plus 3. And that's it. Okay, let's try one more together, just so you can see how we write these out. I'm going to do it all at once now, okay? So this is going to be x minus 4 equals 0. Well, that's going to be x equals 4, and my 4 is going to go here. I'm going to use my coefficients here, so this is going to be 2, negative 11, 11, 4, and 4. I'm going to drop my 2 down. 4 times 2. That is going to go ahead and be 2. It's going to be 8. Negative 11 and 8, that's going to add to be negative 3. 4 times negative 3 is negative 12. Okay. This is going to leave me with a negative 1. 4 times negative 1 is negative 4. This is going to leave me with 0. And for my remainder portion, which I didn't make a long enough line for, there we go. 4 times 0 is 0. That leaves me a remainder of 4. Well, if I started with an x to the 4th, that means I need to drop it down 1 and go to 3 because this was to the power of 1, right? So again, that's x to the 4th divided by x, because that's what we did here. That would be x to the 3rd. So I know that this needs to be an x to the 3rd polynomial. So this is going to be 2x to the 3rd minus 3x squared, going in decreasing order here, minus 1x to the first power plus 0 as a constant, so we don't have to write the plus 0 unless you want to, plus 4 over what we divided by. We divided by an x minus 4. And that is your final answer. Synthetic division seems to be one of the best things ever, honestly. And a lot of my other students really, really do like it. So I think it's kind of fun. All right, let's go ahead and do this one. We're going to knock these ones out, and I'm just going to divide these until we get to the last one, and we'll see how it goes there. So I'm not even going to write it out. What I'm going to do is I'm going to look for remainders here, and I'm going to match my coefficients. So I'm going to start with the first one. I know that this is all of them are dividing by the same thing. So this is x minus 4 equals 0. This is going to be x equals 4. Put your 4 here. My coefficients for number 9 are 1, negative 1, and my constant term is negative 8. I'm going to drop the 1 down. 4 times 1, 4, 3, and this is going to leave me with a 12 and a remainder of 4. Well, remainder of 4 would be this one, right? Because this has your 4 remainder, okay? And then we also have the coefficients 1 and the constant term 3. So 1 and 3. Okay, so 9 goes to A. Okay, let's do the rest of them. We're going to have 4. I'm going to put in the constant and coefficient terms for number 10. This is going to be 1, negative 1, positive 8 this time. Drop my 1, 4, 3, 12, 26, I believe. Or, oops, 24. Okay. Or is it 24 or 28? I think it's 20. It's 20. I have no idea where I came up with 24. There we go. So I see this one has a 20 as a remainder, and my coefficients are the same. I've got my 1 and my 3. So 10 goes to D. I'm going to do the same thing. We have 4, here and here. And then we've got 1, 1, negative 8. Drop your 1, 4, 5, 20, and that one is going to be 12. So a remainder of 12, well, that one looks like B. I'm going to pop it up in here. And then we also know, finally, this has to go with C, right? But for just laughs, I'm going to go ahead and do it myself. I'm going to go ahead and do it just to practice. My coefficients are 1, 1, 8. So 1, 1, 8. Drop my 1, 1, 4, 5, 20. There we go. There's 28. 28. And that's it. That's all she wrote. Okay, let's go ahead and on this side, we're going to use synthetic division to evaluate the function at a given value. So typically we would say, okay, well, typically we would say, all right, well, that would be f of negative 4, right? If I wanted to plug, or 2, and I'd plug it in, and I would do all the work, and then you would get something like negative 48, right? Just like we did in 4.1, right? Instead, we're going to use synthetic division to solve it for us, okay? And the solution, you're going to notice, is the remainder. So I have 2, because x equals 2, so I don't have to solve it out this time, okay? We're going to have negative 3, 4, negative 17, negative 6. Drop my 3. That's going to be negative 6. That's going to be negative 2. That's going to be negative 4. This is going to be negative 21. This is going to be negative 42 with a remainder of, oops, let me make this a little neater here. Oh my goodness, I'm trying to make this look nice, but it's not good enough. Negative 48, and you notice that that is the solution. So f of 2 is negative 48. And that's it. That's why we like synthetic division, because it allows us to do these things just a little faster. Hello, hello. Let's go ahead and get into chapter 4. Most of these have already been done in class, so we're just going to finish up the last couple of problems here. So this is 4.1 graphing polynomials. You'll notice it's in a different form. I just did this to give myself some extra room, and you can find this blank sheet in ThinkWave as well, if you'd like to use this. So all those problems 1 through 4 of the extra practice for 4.1 have already been done. We also did 5 in class, and we're going to go ahead and start with number 6. So this one we have to evaluate when the function is at, when x is at negative 4. So what that means is we are going to replace every x with negative 4. Remember to use your parentheses. We want to be concise with how we write things here. All right. So put it all in parentheses, and I'm just going to go ahead and solve it out. So negative 4 to the 4th, that would leave me with 256 minus 32. Negative 4 squared is 16 plus 256. Okay, this is going to be 256 minus 512 plus 256. 256 and 256, those add to be 512 minus 512. That means that g of negative 4 is 0. Go ahead and box that up. Oops. I didn't want a polygon that ugly. Or quadrilateral, that may be a better word to use there. All right. Next thing that we're going to go ahead and look at is we're going to describe the end behavior of the function. So we're going to look at problem 8, number 7 we did in class. And I've already rearranged it to be in standard form. Standard form, again, is where we have, the highest exponent first, and then we go all the way down in decreasing exponent order until we're at the constant term. Okay? Well, I know that it is a odd exponent, so odd degree. Odd And I know that my leading coefficient is greater than 0, so it's positive, right? Well, the first function that comes to my mind that is odd and positive is going to be, let me read this here, hold on, leading coefficient is greater than 0, is going to be this one here. This is the x to the third, the cubic function, right? And I know that this function is going to look very similar to it and behavior-wise. You can also look at the chart that was provided in the lesson notes. So I know that as x approaches infinity, so as we go this way on our graph, my y value is going towards a positive direction. So f of x is going towards infinity. So infinity, just think of it as a positive direction, right? We can go this way an infinite amount of times, right? And we'll notice that my y value is always increasing an infinite amount of times when we do that. So then we have one more statement to write, is as x approaches negative infinity, okay, f of x will also approach negative infinity. And that is going this way. So as we go this way on our graph, my y value is decreasing. Okay. Go ahead and flip this over. So I've done a lot of work for exercise 10, and that's because we hadn't quite talked about factoring that kind of polynomial just yet. So you could have used a table, but I went ahead and factored it because you're watching this video after we learned how to factor it. And I did it for you. So here are my x values that I've done. And so I have set each of these to 0 to find my x-intercepts. So then you take each factor and you set each factor equal to 0. So let's go ahead and solve each factor. This is going to be x equals 2. This is going to be x equals negative 2. And this one I'm going to go ahead and work out a little bit more. So this is going to be negative 4 equals x squared. And we know that when we take the square root, right, that's going to be x equals plus or minus 2i. Because of the negative underneath the radical here. Remember that the square root of negative 1 is i. So if you have the square root of negative 1 times 4, that's the same thing as saying the square root of negative 1 times the square root of 4. So that would be 2i. All right, so these are our x-intercepts here. So we can write this as 2, 0, and then negative 2, 0. And these two here are going to be 2i, 0, and negative 2i, 0. Now we haven't learned how to graph these ones yet, so we're not going to graph those ones, but I am going to do this one. And then my y-intercept I've gone ahead and solved for. The y-intercept is when the x value is equal to 0, and I wrote this backwards. That's so silly. Here. There we go. That looks so much better. Now it's a y-intercept, yeah? So you set the x value is equal to 0, and then you solve, and you'll get 16. You'll notice that you are going to get the constant term, and that's pretty much the same thing for all polynomials. If we look back over here, the y-intercept of this function would be this. The y-intercept of this function is this, and for this one, it's going to be this, negative 2. Okay, so these are your x-intercepts. Okay, I've gone ahead and inserted my graph here, right? And I know that I'm going to have a point at 2 and at negative 2. I also know that my y-intercept is at 16, so this is going to be 4, 8, 12, 16. And I know that it's to the 4th degree. 4th degree function, so here's our 2nd degree function, right? Here's our 3rd. And here is our 4th. Okay, but you'll notice that my a value is negative, so I'm going to need to do this. We're going to need to flip it over. So I'm using that end behavior to help me guess what this graph is going to look like. Okay, so remember, we're curve sketching. It doesn't have to be exact. So I know that this is going to look probably something like this. Oops, not what I meant to do. Okay. All right. Another way that we could go ahead and write this one is we can change the axes, because, oops. Trying to change the axes here and go all the way back, because I think that would make it look a little bit nicer too. So I'm going to change these, and I'm going to change this over to 1, 2, 3, 4. This is going to be 2. 1, 2, 3, 4. This is going to be -2. And if I change this, it should look a little bit nicer. So 4, 8, 12, 16. There we go. I like this one a little bit better. And again, it doesn't have to be perfect. We are curve sketching here. Awesome. Okay. Go ahead and turn it over this way. So adding and subtracting and multiplying polynomials. Here, we're just going to distribute our positive sign here, this little addition sign. That is because we want to get used to distributing the negatives. So if you do it for everything, you're not going to forget to do it for the negatives right now, right? So I'm going to distribute that positive. Remember, a positive times a positive, this is going to stay, or positive times a negative is still going to be -x squared. A positive times a positive is still going to be 7x. And a positive times a positive is still going to be plus 8. Okay? And this is going to be -4x squared minus 6x plus 18. Okay? Now, I'm going to go ahead and take this, and we're going to simplify our terms. Yeah? So 4x squared, we're going to start here, do this in green, cross them out. 4x squared, -4x squared and -x squared, those add to be -5x squared. Okay? And then what we're going to do is we're going to go ahead and do -6x and 7x. So those add to be plus x. Okay? And then 18 and 8 is going to be plus 26. And that's your answer. So you just combine like terms. Again, what is up with these quadrilaterals, man? I just want a rectangle. There we go. Okay. Same thing here, we're going to distribute the negative. So I'm going to write the first one just as it is. This is 4.2. Distribute my negative, so this is going to be plus 11x to the 4th minus 5x squared. This is going to take up two spaces here. Minus, or plus 7x minus 13. Okay? And now I'm just going to cancel these things out here. So I see -11x to the 4th and positive 11x to the 4th, so those go away. Then I see -x to the 3rd. I don't see anything else, so I'm just going to rewrite it down here. Okay. I see -3x squared and -5x squared. That's going to be -8x squared. Okay. I see 10x and 7x. That's going to be 17. And then I see -2 and -13, which they add to be -15. I got another trapezoid. Oh my gosh. There we go. Okay. I'm actually going to move this over. I feel like it would be. Yeah, there we go. Okay. Here in exercise 4 through 5 of 4.2, we're going to go ahead and find the product. And the way that I'm going to do this is, again, just distributing my situation here. So we're going to add the exponents that we learned in chapter 5 as well. This one's also from Algebra 1, but we're also going to multiply the coefficients. So I'm going to go ahead and distribute this one piece at a time here. So this is going to be 4x and then 2 plus 3, that's 5, so 4x to the 5th. Okay. And then we're going to multiply 2x squared and negative x squared, which is going to be negative 2x, and then add the exponents to the 4th. Remember, this only works if they have the same base, right? Multiply those. That's going to be plus 6, because 3 times 2 is 6, x to the, and there's a secret 1, so that's going to be to the 3rd. And then last but not least, we're going to go ahead and do to the multiply with the 5th here. So it's going to be negative 10x squared. And I don't think there is any other exponents that we have to deal with here. Yeah, I think that's just about it. All right, let's take a look at these pieces of multiplication for 5 and 6. And I'm going to choose to do box method rather than the distributed method that we were doing in class. This is just going to give you another option here. Distribution is absolutely wonderful. I love it, but sometimes it can get a little bit confusing. So we're going to try the box method, and I've highlighted it each color, so blue goes with the terms of blue. So I took 3x squared and put it in its own fancy thing. I took negative 6x and put it in its own fancy thing. Same thing for our function here, or our polynomial there, okay? So I'm just going to fill it in as normal. So I'm going to multiply these two numbers, and that's how this is going to work. And then multiply these, multiply these, multiply, 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 and so on and so on. Okay? So we're going to do 3x squared and x to the 4th. That's going to be 3x to the 6th. This is going to be negative 30x to the 4th. This is going to be 75x squared. Then we'll get negative 6x to the 5th. We'll get 60x to the 3rd. And negative 150x. We'll get negative x to the 4th. 10x squared. And negative 25. Okay? And then we're just going to go ahead and combine all of these terms that I've written in black. We're just going to write them out as we see fit, yeah? So I'm going to do 3x to the 6th because I don't see another one that looks like that, right? Cross it out. I see a x to the 5th. That's going to be minus 6x to the 5th. Okay. I see an x to the 4th. So that's going to be negative 30x to the 4th. Okay. Oh, I see 2x to the 4th actually. I see one down here. So I have to do negative 30 minus 1. So that would be negative 31. Okay. And so what I did was I added these terms together here. If they're the same, you add them together. I see a 3rd. So this would be 60x to the 3rd. I don't see another x to the 3rd. I see 2x to the 2nd power, so that's 75 and 10, which is going to give me 85, so 85x squared. Okay. I'm going to give myself some more room here, because this one's a long polynomial. Okay, and then we have negative 150x. I don't see another x to the 1st, so I'm just going to write minus 150x. And last but not least is negative 25. Okay. let's go ahead and do this next one. So this one's going to require 2 tables, and you'll see why. Again, I've color-coded it the best that I can. So for this first box, we're going to get x squared. We're going to get x, negative 2x, and negative 2. Okay? This is going to come together to create, to create the polynomial x squared minus x minus 2. So that's going to go in purple right here. So let me get my purple going. X squared minus x minus 2. And that's going to go in here. So this is going to be x squared minus x minus 2. And I'm going to go ahead and write it out. So this one is x to the third. This one is negative x squared. This one is negative 2x. This is 6x squared, negative 6x, and negative 12. And those are going to come together. So this is our final polynomial here, right? Oops. And this is going to be x to the third. I don't see another one. Oops. I didn't mean to make it little tiny ellipse there. There we go. I see 2x to the squared, or x to the second power, so I'm going to combine those. So 6 minus 1, that's going to be 5, so plus 5x squared. Okay, I see a negative 2x and I see a negative 6x, and those are going to add to be negative 8. So negative 8x minus 12. Okay. And that's going to be your answer. So this polynomial is equal to x to the third plus 5x squared minus 8x minus 12. Let me go ahead and box that up. Okay. The rest of this on the page is notes from class.